Hi everyone, in this video I am going to explain the concept of bit fields in C programming language. So before I am going to explain this program, so I will give you a small information about a bit fields. So a bit field is a data structure which allows the programmer to allocate a memory for structures and union in bit format. So in general, when we declare any variable or any user-defined data types that may be of array, structures or unions, whatever it will be. So the compiler will reserve a memory in byte formats. Suppose if you are taken a variable of type integer, so now the compiler will reserve 4 bytes of memory for you. If you are using character, so now it will reserve 1 byte of memory for you. So this structure and unions are the user-defined data types. So the user has an idea of how much memory will they occupy in future in their programming. So in general, in structures and unions concept, when we declare some data members, so sometimes we are not using that much of memory which is reserved for our structures and unions. So there will be an internal memory wastages. So we that wasted memory we are not using for any purpose in our programming. So now we have to utilize our computer memory in an efficient manner by using this bit field concept. So that is nothing but we are asking the compiler for instead of reserving a memory in bytes, so we ask to reserve a memory in bits format. So the idea behind to use the memory in efficient manner is, so when we know the value of a field or a group of fields will never exceed a limit or within a small range in our programming, then we go with the concept of bit fields. So this is a syntax how we are using bit field concept in C. So this bit field concept is always used with a structures and unions. So suppose here we are using with structure. So now we have to use a struct keyword. Here we have to provide the structure name. Within that structure name, we are trying to define our data members. So if you know that, so a particular data member is having this many of bits is required. So then we have to use this bit field concept. So we have to extend the definition of your data members in a structures. That is nothing but we have to use a colon symbol. After that colon symbol, we have to specify how many bits you want to store that particular data member. So here size in bits is nothing but a width of a bit field. So I think now you can understand what is a bit field in C. So now try to explain this program. So here I wrote two versions of programs in a single program. So I'm taking two structures. I try to display the size of this structure with and without using the bit fields concept. So here it is our header file stdio.h, so which is a standard input output header file. So later it will be recognize your printf and scanf statements in program. So this is a struct. So I'm creating one structure named date info. So you have to remember that C is a case sensitive language. So it will be differentiated these two names because see here, because both will be a date info, but here everything is in small letters and here one letter in capital letters. So these two names are different in a C compiler mind. So now in this date info structure, so I'm using three data members. So here my program is I want to display the system date. So now the date will consisting three parts. One is day and second one is month and third one is year. So we all know that you can take the calendar. So every month the maximum it consisting of the days are 31. It doesn't be exceeded more than this 31 figure. And always we can take the months. So in a calendar we have maximum of 12 months. So that is also not exceeded. And now coming to year. So here we are not specifying that we can take any year, that may be of 1800 something or 1900 something or 2000 something. So we cannot specify that this many bits will be occupied for this year. So we cannot use with that. Now coming this concept is that we are not using any bit fields concept in this structure. We simply define one structure. That structure name is date info, and which consisting three data members. One is of type unsigned integer, and here D is used for taking a date, M is used for taking the month, and Y is used for taking the year. Okay, and I'm declaring the same structure. So here I'm trying to use bit field concept. Okay, so see here, here also my structure name is date info, and here I'm declaring my date is of type integer. So I already said every month is having the maximum date value is 31. So now you can represent 31 in binary format, because I already said bit field will be work with a bit formats. So it will be not in a byte format. Suppose if I want to take a binary representation for 31. So how I can take? So I can use a code that is 168421 code actually for representing this 32 in binary format. But 8421 by using this digits, so I cannot take the maximum of 31 value. For that I'm extended this, so I'll take the next value as 16. So now we can see I want 31. So which digits I can add to get 31 here? So 24 plus 4 28, 28 plus 2 30. So after that one 31. So now I'll be take each and every digit of this will be 1 1 1 1. So now I get 31 is a binary equivalent for this decimal number 31. So I have 5 ones. So now these 5 ones are represented the binary equivalent of this 31. So I can use maximum of 5 bits to take any values in between 0 to 31. So because of that, even integer will occupy 4 bytes of memory. So I'm asking the compiler, please give me only 5 bits of space for my data member D. So now coming to our month. So we all know our calendar is having only 12 months. So now for representing 12 in binary format, so I can use simply 8421 code. See 8421 code format. So now I want 12. So simply I can enable the bits 8 and 4 to 1 1, because 8 plus 4 is 12. And then the remaining values I will taken as 0 0. So now 1 1 0 0 is a binary equivalent to 12. So I want to take the values in between 0 to 12. So only 4 bits are enough for me. So here also I am requesting the compiler, instead of reserving 4 bytes of memory for my integer variable, simply I am asking for 4 bits. And then this is of year. Okay, so this is my structures, 2 structures. Here I didn't use any concept of bit fields, and here I am using the concept of bit fields. How we can say we are using bit fields? Because here we have a colon symbol, and then we have the number of bits we required for this particular data member. I already shown the syntax how to implement a bit field concept. So that's why I said this is a concept which we are using, the bit field concept. So in main function, what I am trying to say is, because I already said it shows the differentiation of memory allocation. So now we are trying to print the size of structure without using bit field concept and with using the bit field concept. Now we can observe that what's happening with our memory allocation. So in this my main function, simply I am taken my printf statements, and these are the statements which will be displayed on my console in this format only. Like I have a dotted lines, and after that, without bit fields concept, again I have a dotted lines. For that purpose only I wrote this 3 lines of code. And after that, here I'm asking to print my compiler what will be the size of my structure. So we all know we have to use the size of function to find the size of any data type that may be of a user defined or predefined data types. Simply we can pass that particular data type or a variable or a data member. So here I want to find the size of structure. I am passing my entire structure here. So what is my structure name? Struct date info. So remember, this is a structure which I cannot use any bit fields concept. Right. So now before we are executing, we'll see how much memory it is required, because I already said structure is a user defined. So before that we already know that how much memory we required. So here is all of type integers. So one integer will take 4 bytes. So here we have 3 bytes. That is 3 data members is of type integers. So 3 multiplied with 4 bytes, that is totally it is a 12 bytes of memory. Okay. So by this printf statement, it will print 12 bytes. And after that, I am assigning my data member values here. Here I am assigning my data member values. So we all know how we can create a variable for a structure. So this is my variable dt1, which I am created for my structure date info. And this is a compile time initialization. So I'm given value of my all data members at the time of programming itself. So this 8 is nothing but I'm provided a date, and this 12 is nothing but I'll provide it as my month, and 2021 I'll give as year. Right, 2021 I'll give as year. So now I'm trying to print these values. So in structures concept, how we can accept the data members of a structure, we can simply use our structure variable along with dot operator, and we are trying to display our data members. So that I'm using here dt1.d and dt1.m and dt1.y. So now, the first program size I already printed here. Now coming to our second structure. So before I am printing the size of my second structure, so simply I am printing these 3 statements on my console. That is dotted lines. In between dotted lines, I am given a heading as bitfield concept used in a structures. So now I wrote the same statement for printing the size of my structure, but here my structure name is changed. So here it will be a small date info, and here it will be a date. In that D is a capital. This is my second structure which I am used a bitfield concept. So now I am trying to display my size of structure, and after that I am taking one more variable to my structure date info, and that variable is dt, and I assign values as 4, 12 and 2021. So I'll assign the same values. So in that printf statement, I am trying to display these values. So for that I am using dt.d, dt.m, dt.y. So because the dt is a variable which I am created for my date info with the concept of bit fields. So now this is a return 0 statement because I wrote this one because my main function is of type integers. So now I'll show you the output. So I try to execute this program. So I'll compile and run this, and you can observe that, see, without bit fields concept. So what is the size of my date structure? It will be a 12 bytes. And what is the date I am trying to display? That is 8/12/2021. And after that, I want to display the size of my structure. So bitfield concept used in structures. So here the size of date is 8 bytes. And you can observe that here date is 4-4. So there I am given 12 as my month. But here it displayed like a negative value. So what is the reason behind that? So because see, I already said the last bit, always either you are using 4-bit or 5-bit format. When you are using signed integers, right, when you are using the signed integers in binary representation, the last bit will be taken as an MSB bit, that is represented as a signed representation. That value is 0, then it will be taken as a positive value. If the maximum, that is MSB bit, is 1, then it will taken as a negative value. See, I'll give that explanation. Here how the 12 value is represented. See, 1100. So now for this 4-bit binary representation, so this is the MSB bit and this is the LSB bit. That is nothing but most significant and least significant bits in my binary representation. So always in signed representation, the MSB bit will be taken as a signed value. So if it is 1, that is nothing but it is a negative value. If it is 0, then it will be taken as a positive value. Now you can observe that if this bit will be taken as a signed representation, and what will be the remaining number? 100 is representation for decimal equivalent of 4. That's why the reason it will show you -4 as your answer. Suppose see, if I take a month in between 0 to 7, then it will be printed as same way, or else you can change this data type as unsigned. Right? Simply you can change this month, the data type as unsigned. Unsigned integer. So again I'll execute this program. Now you can find the difference. See here. So now you got the same thing. Because whenever you given an integer as your data type, defaultly it will taken as a signed integer. So when you represent the bits in binary format, the most significant bit will be taken as signed representation. If it is 1, it will be treated as a negative value. If it is 0, then it will be treated as a positive value. So that is of the reason you got the output like this in previous execution. So I think you can understand this program. Thank you.